Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we dive into the secret world of submarine hunting, showing how ships, aircraft, and AI-powered sensors combine acoustic and magnetic clues to pinpoint a submarine's location and build the underwater picture needed for a precise and timely torpedo launch. This mission begins with a daunting challenge. Detecting a hidden submarine is one of the most demanding tasks for a modern navy. A submarine can slip silently through deep waters, relying on stealth coatings, careful design, and quiet propulsion. To engage with torpedoes, which require accurate location and targeting, navies must first pierce that underwater cloak. Over decades, they have built a layered system of sensors, combining acoustic, magnetic, and even wake detection technologies to reveal submarines lurking beneath the waves. At the core of submarine detection lies sonar technology. Ships are often equipped with hull-mounted sonar arrays that listen passively for the subtle sounds of a submarine, engine noise, propeller cavitation, or movement through water. More powerful, however, are towed array sonar systems, long cables with many hydrophones towed behind a ship. Because these lie away from the ship's own noise, they achieve a far better signal-to-noise ratio. Low-frequency detection makes them especially suited for modern, quiet submarines. Such towed arrays remain the primary tool for contemporary anti-submarine warfare, or ASW, enabling detection across extended ranges and depths. Surface ships alone cannot cover every patch of ocean. Maritime patrol aircraft and helicopters expand coverage by deploying sonobuoys, small, expendable sensor units that float on the surface and drop hydrophones to listen underwater. Some sonobuoys operate passively, listening silently for noise. Others actively emit sound pulses and record echoes to locate a submerged target. Naval helicopters can also use dipping sonar, lowering a sonar sensor into the water while hovering to detect submarines near the surface or at medium depths. Acoustic detection has limitations. Quiet submarines with anechoic coatings, or those operating at depth, may avoid sonar detection. To complement sonar, navies also employ non-acoustic techniques. One such is magnetic anomaly detection, or MAD. Aircraft or helicopters fly low over the sea. Sensors detect minute disturbances in Earth's magnetic field caused by a ferromagnetic submarine hull. Although detection range is limited, submarines must be relatively shallow. MAD remains useful, especially in littoral or shallow water scenarios. In addition, specialist systems developed during the Cold War looked for other signs: changes in water refractive index, turbulence in the wake, or even chemical traces emanating from a submarine reactor or exhaust. Such methods sought to spot the submarine's footprint, even without relying on sound. Submarines themselves continue to evolve. Modern boats use anechoic coatings that absorb or scatter sonar waves, streamlined hulls, and specially shaped propellers to reduce cavitation noise, and quiet propulsion systems such as air-independent or electric drives. These advances make acoustic detection far harder, which in turn increases the importance of high-sensitivity towed arrays, non-acoustic sensors, and multi-platform cooperation. Modern anti-submarine warfare seldom relies on a single sensor. Instead, navies combine data from hull sonars, towed arrays, sonobuoys, dipping sonar, MAD sensors, and surveillance aircraft or satellites. Combat systems used by warships fuse passive and active sonar data into a unified underwater picture. This integration enables detection, classification, and targeting of submarines in a coherent operational context. By combining different data streams, navies can cross-check contacts, estimate submarine position, depth, and course, and thus prepare for a torpedo launch with minimal margin of error. To keep pace with quieter submarines and complex ocean conditions, navies are increasingly relying on data processing, signal analysis, and sensor fusion. Modern ASW systems incorporate automated classification algorithms, noise filtering, and even artificial intelligence-driven analytics to distinguish real submarine contacts from marine life, surface ships, or sea clutter. In some navies, sonobuoys and towed arrays are being complemented with newer sensors, including magnetic field sensors, wake detectors, and oceanographic monitoring systems to expand detection capability across acoustic and non-acoustic domains. Once a submarine threat is detected and localized, with bearing, distance, depth, and likely course estimated, the commanding vessel can track and classify the contact. Confirming it is indeed a hostile submarine allows for a firing solution, laying in torpedo direction, calculating target motion, and timing the launch. The accuracy of detection and classification is vital. Torpedoes are expensive and dangerous, and mistakes can lead to catastrophic friendly fire or wasted resources. Because modern submarines operate quietly and sometimes at great depth, the reliability of the firing solution depends heavily on sensor fusion, continuous tracking, and precise acoustic or magnetic data. Only when the contact is consistently verified and classified does a Navy commit to firing. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.